So now let's look at how we can transform columns in our data frames. And then we'll look at how we can use this to help us do more customized sorts. So to add a column, the easiest way is just to use the bracket operator. And so let's actually jump over to our Jupyter notebook to play with this for a minute. We're going to stick with the same baby names data frame that we've been using. So I'm just going to scroll. We're in this pandas part 2. I'm going to scroll down to the adding, removing, and modifying columns. Let me just remind ourselves of what our data frame looks like. This was the Social Security data of the names of babies born in the US, and then we just grabbed the subset of Colorado babies. So I could add a column. In fact, let's say I would like to add a column that's going to actually count the lengths of the names. So here I would want this to be 4. I would want this one to be 5. I'm going to add a new column. To do that first, I need a function that'll count the lengths of these names. And so this is when I can call baby names, call the name column, and then call the .str method. And then it actually has its own method length, or .len. And so just for us to see, let me pop back over here. These string methods are very useful to operate on arrays. And so you basically, you can use the str attribute and generally have names matching the built-in string methods that you might want to do. So lower, upper, length. And so you can play here with different possible things you might want to do with strings. Let's go back. So if I do .str.length, I'm just going to show you the series I get back, and then we'll see how we could set that equal to a new column. So I'm getting this series that again is telling me that the length of the first entry was 4, the length of the second entry's name was 5. And so now I can say, all right, let's create a new column named name lengths and set it equal to that series. And so if I do that, then I'm going to get the new column out that exactly calculates what I'd like, name lengths. So that's the quickest way to do it. The other way you can do it is actually using the .assign. And so I'm just going to show that here. Let's actually do a slightly different column. We'll take the name lengths, the baby name lengths that we calculated, add 1 to it just so you can see the difference in the column. And there we go. Now I have a new column. Not really useful, but it's 1 more than my name lengths. I will point out that when we've done this, notice I have to actually assign. Actually, I have to set this equal to my data frame. Otherwise, it's not saved. The default when you call methods on a data frame is that it's saved as a copy. So let me show you what would happen. Let's actually just go back up above. I'm just going to reload baby names just so you can see what would happen had I not saved it. Okay, and we'll just go right to option 2. So I'm just going to do this. So baby names assign. Great. So it shows up when I call it. This is actually a copy though, because if I now go, let's call baby names again. Right? I call it and it's no longer saved. So if you want to add a column by using .assign, you actually need to then set baby names equal to that new data frame, and then it will be saved here. Okay. I'm going to pop back to our slides. Okay, and then, oh, this is also just emphasizing the copy issue. And so this will come up frequently if you ever have issues like, wait, this is not being applied, this is not working. Just make sure that you've actually updated your data frame. All right, now you can modify a column very similar to what we just did using your bracket reference. So suppose now I want to modify my name lengths to be one less than its original value for some unknown reason. In that case, I'm just going to rename it, calling the same name, baby names, name lengths, and then set it equal to what it was before -1, and it'll just replace it there. Now, these are for really basic updates. So notice, well, all I wanted to do was something simple that involved just like adding, or it involved a built-in function, that .str.length that was already available to me. If I want to do something more custom, that's not already a built-in function and not something as simple as just subtracting 1, then I have two options. I have what's called the map and the apply methods. So I'm actually going to pop back over to our notebook to show us this. Okay, so suppose now that I'm making up just a really random thing that I wanted to do just to show you the flexibility of this. So suppose that I wanted to count the number of times that AR shows up in a given name, right? Not that there's a real reason for this, just to show you that if I want to do something more intricate than what was already built in. So I'm creating my own function that is going to take a string as its input, and it's going to return string.count AR. So this is using a built-in method that's going to do this for me. All right, now if I want to apply this function to each name in the name column, I can do .map and then call my function. And then this is now going to create a new column, right? AR count. And the way it's getting the entries for that column is taking the baby name's name here and then sending it through my function. And that's how I'm getting, there was one instance of AR and Mary, there's 2 instances of AR and Margaret, and the rest of them don't have AR. I will just point out that this is also a key time where you could do what's called a lambda function. And this is basically just like a user-defined function, but for really simple expressions. So they're sometimes called anonymous functions in Python, but the format is lambda of your arguments. So see, my argument was string here. I'm just going to call it x. And then you do the expression right afterwards. So just what I would want to return. So this is just shortcut, kind of quicker way to write the same thing I had above, but just with less code. And it will run and result in the exact same output. So that's helpful if I have something I want to, some function I'd like to apply to a given column to create a new column or to modify a current column. Sometimes I have a function that I would like to apply to multiple columns. So again, I'm making up a very interesting, not useful use case, but suppose that I wanted to create a new column where the value of it was for a given row, it's going to be the max of count and name lengths for a given row, and then divide by the year. Okay, again, not for practical purposes, just to show you how you do it. So in this case, I'm creating my own function that's taking a row in this case as input, and then it's going to call the count of the count value of the row, the name length value of the row, and then divide by the year value of the row. And so now I can do babynames.apply test function, and axis equals 1 is it means I'm going to use a function on each row. If I want to use a function on a given column, then I would have axis is equal to 0. And so again, this is now going to allow me some flexibility. And this is angry about what? Let's see. This one wants name lengths. Oh, okay. I called name lengths and I don't think I even had that right, because I didn't run, let's call name lengths too. So this is a great example. If you create a function that's calling a column that doesn't exist in your data frame, this won't work. But now since name lengths 2 exists in my data frame, now it's going to work. And again, it's going to create my new column, which is a meaningless value, but just something that I was able to do custom based on the information for a given row. Okay, so map and apply are useful in those more custom situations. As a reminder, the default for .apply is your axis is 0, which is applying a function to each column. You could see in my example, because I wanted to apply it row-wise, I set axis equal to 1. Okay, so renaming a column is actually really easy. It's using the creatively named .rename method. It's going to take in a dictionary that's mapping your old column name to their new one. Again, we're just reminding you that by default, if I just called babynames.rename, it would not save. It would save to a copy, and I wouldn't have any updates to my original. So to apply this, I have to update my data frame to this new copy. And then I will get this. And then finally, I can drop columns using the .drop method. The default is actually assuming you're dropping a row by default. And so if you want to drop a column, you can switch access to be columns. So here we could drop that extra column that we created, and we're back. Whoops, we're back to the original data frame. All right, so now that we have the basics, let's revisit our sorting question from the last video to see how we could answer a little bit more interesting sorting question. So we wanted to find the longest names in Colorado. So sorting by name wasn't going to work. But now we know what we really need to do. We have a couple options. We could add a new column that is going to count the length of the baby names, and then I could sort based on that column. And so here I'm showing us adding that column just by using the built-in .str.length function. And then I have ascending equals false so that it's going in descending order. This is also a really good time to check if you think that your data has maybe some self-imposed limits on the number of characters that were allowed in. Like, is it really that the name ends at 11? Or maybe there was a built-in cutoff and they cut off the names at 11 characters. You just want to check that kind of stuff if you were really using this for a real analysis, because sometimes your max name lengths is actually just an artifact of like a cutoff process in the data. So the second way we can do this is actually using what's called the key argument. And here I am showing it using a lambda function. You don't have to use the lambda function. You could just create, your own custom function and just set key equal to custom function. But in this case, it's going to then take whatever column you want to sort on, name, but it's going to do the sorting by applying this function to name. So it's applying this, and then this is now what it'll sort. So you can see it's going to be sorting based on which name had my, let's see, this has ascending is equal to, yeah. So which name has this value that's the largest. So it's not saving it as a new column. I can't see it, but it is using it in its calculation of how to actually return this for you. So it's similar to this previous one that we have, but it's basically doing this part underneath the hood and not creating this column, just doing it all for you in one call. And then finally, I'm just going to point out that we could use the map function if you, for example, wanted to sort. Again, this is a very made up, contrived example, but suppose I want the number of occurrences of DRs and EAs. I could use the map function to create a new column, just like we did up above when we were looking at ARs, and then sort values based on my new column. So very similar, just now applying map and sort values together to help answer a question. So these are just a couple of quick examples of some of the functionality and things that you can do as you start to want to do more complicated sorts.